everyone. It's Susanna here with Health Ed Solutions, and today's lesson is on cardiac muscle cells. Don't forget to visit us online at healthedsolutions.com for more free content. Now, let's get started. Here we can see a close-up of the myocytes of the heart wall. Intercalated discs connect cardiac myocytes end to end. Cardiac muscle cells are also branched, typically only have one nucleus each, and contain many mitochondria. They prefer fat for fuel, and that means that they require constant oxygen delivery and healthy mitochondria. Scattered throughout the myocardium are fibroblasts. Fibroblasts make collagen fibers that support the overall cardiac structure and prevent inappropriate electrical signaling. If someone suffers damage to the heart muscle, for example, from a heart attack, then activated fibroblasts, seen here, will replace muscle cells with excessive collagen scar tissue. After a heart attack, proteins from damaged cells spill into the bloodstream. Troponin is the best known of these, and it can be a clue as to the degree of heart damage that has occurred. At each intercalated disc, specialized protein connections called desmosomes anchor the cardiac cells together. Gap junctions allow ions, such as sodium and calcium, to freely flow between neighboring cells. In this way, no cells are left out from depolarization, and the heart muscle contracts as a unit. Just as in skeletal muscle, microscopically visible striations, which literally means stripes, these are formed by the overlap of actin and myosin filamentous proteins. These overlapping proteins form what is called a sarcomere, and this word literally means flesh measure. These sarcomeres contract in long, repeating rows. Myosin pulls on actin, which shortens the muscle fibers. Watch this. Myosin pulls on actin, shortening the muscle fibers. One more time. Myosin pulls on actin, shortening the muscle fibers. A contraction requires depolarization of the cell membrane, which is followed by calcium entry, which triggers further release of calcium from intracellular stores. This released calcium floods all around the sarcomeres and interacts with a protein that we've talked about called troponin. This calcium and troponin interaction allows myosin to grab onto actin and pull like a power stroke. Adequate ATP allows myosin to let go of actin, whereas adequate calcium allows myosin to reattach for another power stroke. Oxygen-deprived cells cannot produce enough ATP, and they die, releasing troponin, seen here, into the bloodstream. Elevated blood levels of a cardiac-specific troponin indicates heart muscle damage. Calcium channel blockers stop the calcium entry that normally triggers intracellular calcium release, and thereby decreases both the frequency of heartbeats and the force of each contraction. In separate videos, I will explain in more detail the mode of action of various cardiac medications. That's it for our lesson today. Thanks for watching, and don't forget to please like and subscribe below.